Hello, and welcome to the Pre-Calculus Podcast. I am your host. This is episode 11.6, Combinations. I want to apologize if anything sounds different or if anything strange happens. I have been kicked out of my normal place, and I am recording from home. So if you hear any weird sounds, it's probably my dog. Okay? So, let's begin. Last episode, we talked about permutations, and now today we're going to be looking at combinations. So, the main difference between a permutation and a combination is that in a combination, the order does not matter. So with these, you're just looking for an entire group. How many times, or how many ways can you make a group of 3 in this case, taking 3 governors out of a committee to form a committee out of 10. Okay, so it doesn't matter who you pick first, second, or third. If you take the governor from Oregon, Washington, and California, even if you picked California first, Oregon second, Washington third, that's the exact same as if you picked Washington, Oregon, then California. So as you see, the order doesn't matter, it's just a group. So this would be anything that if you need a group that doesn't have any rankings, so there's not like a president, a vice president, there's not a first, second, or third. It doesn't matter which one's first, second, or third, which one, there's not like a one's better than the other. That's where you would use a combination. So a combination is just a group of 3 out of 10. And with that, you would use a combination, which again, your TI-84 calculators are able to do that. Okay, and this is the one that's a C on it. So when you looked up and you found how to do the P, the C is the other one that you would see on the same screen, and that gets you your combination. Okay, so if you were to check 10C3, so a combination, how many groups of 3 governors can you make out of 10 to form a committee? You would see you would be able to make about 120 different groups could be made. Okay, so here's the formula for our our combination, which as you notice is slightly different than a permutation because the only difference is this k factorial on the bottom. So the combination is always going to have a k factorial on the bottom along with the n minus k factorial. So that's the only difference between it, between the two. Now, these are 3 different ways of writing the same formula. This one you don't have to worry about too much. It's more of a absolute formula for it, but n factorial over k factorial times n minus k factorial is one that you could use, or if you wanted to find the permutation, you just divide it by whatever k factorial was, and that's going to get you the same answer. Okay, so one thing you'll notice with this, especially with this equation, is that the NCK will always be less than or equal to NPK. Okay, so a combination should always be less than or equal to a permutation. Now there's only a few times that it'll be actually equal to each other, but the permutation should always be larger because again the order matters. If I was just saying, okay, how many ways can you organize California, Washington, and Oregon? You can go, okay, well I can do California, Washington, Oregon. I can do California, Oregon, Washington. I can go Oregon. So you see you end up with 6 different ones. But how many groups of those 3 if the order don't matter? You can only make 1. Okay, so that's where the difference comes into play. So permutation will always be more than the combination because the order matters in a permutation. The order does not matter. So on a test, the student is to select 10 out of the 13 questions. How many ways can this be done? So with this, the order doesn't matter with this problem because if I decide to answer numbers 1 through 10, it doesn't matter if I did number 10 first or number 8 first. I still answered 1 through 10. Okay, so what we have here is that we have a combination. So this would end up being a 13C10 for our combination. So when we plug that in and we check it, we end up with about 286 different ways that we can make a group of 10 out of 13. Okay, so 5 students must be chosen for a group for a prom committee. And so we want to find the formulas for how many possibilities there are given T number of students. So basically what we're wanting to do here is that we want to make a formula so that we're able to basically plug in how many students there are year to year. So, one year there might be 70 students that can do it, and the next year there could be 30 students that could do it, the next year there could be 120 students. So you see how that T could change year to year, and we want to see what the combination is. And so we'd have to figure out what that formula would be. Well, that top number, okay, for our formula, it's always going to be a combination of T C5, which that top number is changing, but it's always 5, and it's a combination because whoever you picked first, it doesn't matter if they are the first person or the last person in the committee, because there's no like president of the prom committee. You're just saying 5 students. So if we use that, we end up with 5 factorial over, or no, T factorial, my bad, T factorial over 5 factorial times T minus 5 factorial. Okay, and that would be our formula that we would have. And as you see, it reduces down. We end up with T times T minus 1 times T minus 2 times T minus 3 times T minus 4 all over 5 factorial. And the reason is because this part eliminates everything from T minus 5 onward. So if there's more than 5 people, it eliminates everything else. So we're left with just that formula. So if there was 1,200 students to choose from, you end up plugging everything in, and you end up with your answer of a large, large, large number that is possible. Okay. All right. That's basically the end of this permutation combination sections. Okay, that's the end of this podcast. So again, remember the key thing here is that with permutation combinations is that a permutation is always going to have more because the order of it matters. Okay, the order in which you pick them matters. The combination, though, it does not matter the order, so you're just looking for groups. All right. Okay. So that's the end of this podcast. I hope you enjoyed. I hope you come back for more, and I hope everything is okay. Right, stop. Don't eat my microphone.